Okay, thank you again. My name is Ian Achola and welcome back to my YouTube channel. Today I want to talk about the rate of work. In this tutorial, I am very sure that you are going to benefit a lot to learn about the rate of work. That is, the physicists call it power. But in simple mathematics, we want just to do the two questions presented on the board. Now, without much ado, let me just start by number one. Tap T1 fills the tank in 8 hours, while T2 empties the same tank in 12 hours. How long does it take to fill the tank if both taps are running? Now T1 is filling the tank. It means that that's the inlet, and the T2 empties the tank, that's the outlet now. We want to determine how much will it take for the two taps to completely fill the tank where the two taps are both opened. So one of the tank is the inlet, and one of the taps is the inlet, and the other tap is the outlet now. Now, how do we go about these questions? That's another problem. Now, we want to know how much time will it take the tank to completely be filled when the two taps are open. Now, since T1 is filling the tank, it means that as T1 does some work of filling the tank, at the same time, T2 is removing the water, that given liquid from the tank, the same tank. Now, to determine the amount of work taken, the amount of water filled by the tank in 1 second, what fraction of liquid will be filled in the tank by the first tap T1 within 1 unit time? Now we say now, if T1, so for T1, if in 8 hours, the fraction of the tank that will be filled in 8 hours with T1 is 1 whole. What about 1 hour? What fraction of the tank will be filled? Because multiply and find that for T1, within 1 hour, the fraction of the tank that will be filled will be an 8 full. Now that is for T1. Now again, for T2, it empties the same tank in 12 hours. Now, if 12 hours, the whole tank will be emptied by T2 when the tank was completely filled. Now, again, we come for T2. T2 will say, if 12 hours, the fraction of the tank is 1 whole. Now, since the tank is being emptied, the fraction that will be emptied is 1 whole tank. Now, what about 1 hour? What fraction will be emptied? We'll find that T2, this is the outlet. It will empty 1/12 whole tank will be empty within 1 hour. Now, if T1 within 1 hour, it fills an 1/8 of the tank, and T2 within 1 hour, it empties a 1/12 of the tank. Now, what fraction will be filled within 1 hour? So the fraction that will be filled within 1 hour, we are going to have the fraction of the tank that will be filled within 1 hour by T1, subtract the fraction of the tank that will be emptied by T2 within 1 hour. So within 1 hour, we have the fraction to be filled is which has been filled by T1 is an 8 minus a 12. So the LCM is 24. That is 3 minus 2, which we have 1/24. So this fraction will be filled within 1 hour. So we say now, if in 1 hour, the fraction that is full is 1/24, what about 1 whole tank? 1 whole tank will be filled within how many hours? So it goes multiply. So the total time that will be taken for the tank to be completely filled, to be completely full, is equal to 24 hours. So this tank will take a total of 24 hours to be completely full when the two taps are running at the given rate. machine B, the same working 10 hours. So and to see, for machine A, if in 6 hours, it takes the whole job, one whole job, what about in 1 hour? What fraction of the job will be complete? So we have 1 by 1 divided by 6. So the full job will be done by 1/6 full. So that is only machine A. It will do 1/6 full of the total job. That's for machine A within 1 hour. Then for B, if it takes 10 hours to complete the same job, that is one whole job, what about 1 hour? How long will it take? So it will, how much work will it done within 1 hour? So if 10 hours, it does the whole job, what about 1 hour? So we have 1 times 1 divided by 10. So this one gives 1/10 whole job. Now let us go to part A. If both machines are working together, how long will it take to complete the work? Now, if machine A working alone, machine A working alone within 1 hour, it works 1/6 of the total job only. But machine B, 1/10 of the total job, because that is the work done within 1 hour individually. Now for the combined effort within 1 hour, you can now work the combined effort. Since they are all working together, so we have 1/6 for A, that is 1/6 for 1 hour, 1/10 for B, the LCM is that is 5 plus 3, so the 8/30. So this is the combined effort within 1 hour. Now for 1 hour, the fraction that will be done is 8/30. What about one whole job? What fraction will be done within 1 hour? We plus multiply, so it is 1 by 1 times 30/8. So by 2, 4 by 2, 15. So the answer is 3.75 hours. So it will take, the two machines take 3.75 hours. That is 3/4 hours. So when they work together, if both machines start working together and machine A breaks down after 2 hours. Now after 2 hours, what fraction of the job will be done? If after 1 hour working together they do 8/30, so we say if one whole job they take 1 hour, 1 hour they work 8/30, that is for 1 hour whole job. What about 2 hours? This one will be equal to, so 2 times 8/30, this gives you 16/30, that is 1 hour. 8/30 times 2, because there are 2 hours. Now, this fraction will be completed within 2 hours. Now, from the whole job, what fraction is remaining? So the remaining fraction is the whole number minus the fraction done within 2 hours, that is 16/30. And this gives you 14/30. So this one is the remaining portion of job that is yet to be completed when machine A breaks down. Now, so this one is the remaining job, and machine A within 1 hour was completing the same job within 1 hour, that is 1/6. Now for A now, it breaks down. It means that it is not working anymore. So I remain with only machine B. So for B, within 1 hour, the fraction of the job that is done within 1 hour is 1/10. So now we say if 1 hour, it completes 1/10 of the whole job. And the fraction of the job that is remaining is 14/30. What about 14/30? How long will it take? We have 14/30 times 1 times the reciprocal 10/3. 10/1 by 10/1 by 10/3. So the answer is 14/3. So we have 14/3 hours. This one is equivalent to 4 whole and 2/3 hours. Subscribe to my YouTube channel and hit the notification bell for more productive mathematics problem. Thank you.